All right, for this last section, we're going to talk about something called Cramer's rule. So remember yesterday I said when we were dealing with determinants that they are used to help us solve a system of equations that has variables, okay? So Cramer's rule is taking those determinants that we talked about and actually applying them to a system of equations so we can solve for the variables. So we're solving for either x or for y. Now when you have a system of equations, it's going to look something like this. Okay, what I'm highlighting there. So you'll have two unknowns, so like an x and a y. They could use any letters really, but most of the time we see x and y. Then you'll have numbers sit in front sometimes, so it might say like 2x, 4y equals 10. Okay, so the 2 in front of the x would be a coefficient, the 4 in front of the y would be a coefficient, and that 10 at the very end would be a constant. When you're using determinants, you have to be able to pull numbers from in front of the letters or those constants at the very end. So we set up to solve for x and y two different ways. So x is when we do the determinant of, like in relation to the x value, the x variable, over the determinant of the system of equations. And then the y is doing the determinant in relation to the y variable over the determinant of the system. So where does that information come from? Well, when you look at these determinants that I have down here, and I think you guys might have to add in on your guys' notes, the little x and the little y here. I don't think I had that in your guys' packet. The top determinant, so this one, that's the determinant of the system. And what you grab are the numbers that are sitting in front of your x and your y's. So just the coefficients go inside of this determinant. Now all of these determinants that we do today are going to be 2 by 2s. So they're going to just be the ones that we cross multiply and subtract like we did yesterday. So if I have the determinant in respect to x to help me set up my equation to solve for x or to solve for y, I use this one instead. And it changes a little bit from the determinant of the system. So this one, I grab those two constants at the very end of the equation. Those go first. They kind of go in place of where the coefficients of the x values went. And then you can see like the b1 and the b2. Those are the numbers in front of the y. Those stay the same. And then down here for the y, it changes once again. This time we keep the coefficients in front of the x where they were, and we put the constants in where the coefficients of the y were. So if you guys just kind of take a note here, these two are the constants at the end of your equation. They kind of just switch places, and they go in place of the coefficients of the letter that you're solving for. So like this one is in place of the x's, and then for the y's, this one's in place of the y constants. And that's going off of that original determinant up there. And then the b's and the a's, those kind of stay in the same spot. It just depends on which value you're trying to solve for. So let me show you an example of how we actually use this. So if I have this system, 3x plus y equals negative 17, negative 4x minus 4y equals 28, I want to solve for x and y. So I need to find those different determinants so that I can then set up the x and the y so I can solve for those values. The first thing I'm going to do is just find my regular determinant of the system. Okay, so coming back up here, I'm doing this one that I circled in red. So I just grab the coefficients that are in front of my x and my y values. So remember, coefficients would be the numbers that sit in front of the letters. So in that first equation where it says 3x plus y, your coefficients would be a 3, that's in front of the x. What number is in front of that y, technically? 1. Okay, and then on the bottom, you grab the same pieces, those coefficients in front of the x and the y. So that one says negative 4x minus 4y. So they both have negative 4 sitting in front of them. Okay, so negative 4, negative 4. All right, let's set up the determinant of, like, in relation to the x. So coming back up here, this is this one. So instead of putting in the x and the x coefficients, we replace those with the constants at the very end of the equation. So that would be the numbers that the equations are equal to. So it says equals negative 17 and 28, so those go in place of the x. And then I still grab my y coefficients, so I'm going to leave the 1 and the negative 4 where they were. Okay, and then the last determinant I need to set up is the one in relation to the y variable. So for this one up here, I leave my x coefficients as is. So I'm going back to my original determinant. I leave the 3 and the negative 4 where they were. Instead of the 1, negative 4, because that was what's in front of the y's, I grab the constants at the very end. So I grab the negative 17 and the 28. As you guys get used to this, you just have to be able to kind of read through your system of equations and know where's the A1, where's the B1, where's the C1, because they're going to be in the same spot every single time. So that once you can identify those terms, you can just start putting them into your determinants. So let's evaluate these so we just get the numbers. So to evaluate, remember all we're doing is we're cross multiplying and we're subtracting. So for this first one, you're going to take 3 times negative 4 minus negative 4 times 1. So that's going to be negative 12 minus negative 4. Watch your signs here. So negative 12, this ends up being added to 4 because you've got double negatives. That equals negative 8. So that's the D, the regular determinant. Okay, so let's go ahead and do these last two here. So negative 17 times negative 4 minus 28 times 1. And then 3 times 28 minus negative 4 times negative 17. So you guys take a second and try to evaluate those. Okay, so for the determinant of your x, I got 40, and the determinant of my y, I got 16. So to finish this up, because I still don't know like what x equals and what y equals, that's what I'm trying to find. I'm going to scroll back up one more time here. This is what I highlighted in the blue right here. So to find my x, I take the determinant in respect to x divided by the regular determinant, and then I do a similar thing for the y. I take the determinant in respect to y and divide by the determinant of the system. So I already have those numbers now, the negative 8, the 40, and the 16. So to find x, we put that 40 over the negative 8. And so that's going to equal negative 5. So that's my x value. And then for the y, similar setup except we're doing the determinant in respect to y. So that would be 16 over negative 8, and that comes out to be negative 2. Okay, and if you write them out separately like this, that's fine. Some will write it as an ordered pair, because technically, since it's a system of equations, they could be graphed. And so these points that we find are coordinates on the line. So this would be negative 5, negative 2. I'm going to accept answers either way, whether you write them out separately like I did to start with, or if you rewrite it as a coordinate. I'll give you credit for either one there. So I want you guys to try to do this second one here. Real quick, do you guys notice how the second equation doesn't have an x value? It just says negative y equals 4. So what, if there's no x value, what number would probably be in front of that x if it's not there? 0. Okay, so when you have to pull like the A2 to set up your determinants, since there's missing an x there, that number is going to be represented by a 0. Okay, so for my regular determinant, I got a -1. For the determinant in respect to x, I got 5, and in respect to y, I got 4. So then to finish up, solve for my x, I take the determinant in respect to x, which is 5, divided by our regular determinant, -1. So I got -5 for that x value. And then for the y value, I take that 4 divided by the -1, I get -4. And that would be my y. And again, if you wrote it as a coordinate, an ordered pair, that's fine. It would be -5, -4.